In section 3.9, we're going to look at the derivatives of exponential and logarithmic functions. And this first video was just going to deal with the first part, the derivatives of exponential functions. If you recall from pre-calc 30, an exponential function or any function of the form y equals b to the x, where b is the base and it's a positive number except the value of 1. And we have our exponent is a variable. Okay, now if we have our base bigger than 1, like this example here, y equals 2 to the x, remember our graph went up like this. And if it's a fraction, our graph was a decreasing exponential function. In calculus, we deal with a special number e, and e is a constant. Okay, so if we look at the function y equals 2 to the x and y equals e to the x, e would just rise a little quicker because its base is bigger than the base of 2. So this number e is a constant. Again, we're going to use a fair bit throughout this course. When we differentiate exponential functions, we'll be dealing with two kinds, those involving the base e and those involving the base a. Okay, and there's basically two different ways. There's two different approaches with these. They're similar, but there's one extra step that's required for base a exponential equation. So let's start with base a, and I'll walk you through the first example, and then I'll give you the formal definition. So let's say that we're given y equals 5 to the 3x. So when we take the derivative of an exponential function is always itself times the derivative of the exponent times the natural logarithm of whatever the base is. And that would be your final answer. You cannot multiply the 3 and the 5 here to get 15 to the 3x. Okay, that's your final answer. Now, some books might write 3ln 5 out front, and then 5 to the 3x, and the brackets might just show you that that's just a coefficient out front of this exponential function. So, in general, if I have an exponential function of the form y equals a to the u, then the derivative with respect to x is going to be the function itself times the derivative of the exponent with respect to x times the natural log of the base. So let's take a look at our next example. So I have 17 raised to the 4x squared. So the derivative is going to be itself times the derivative of the exponent times the natural log of the base. Pretty easy three-step process. Now, when we have base e, these questions actually get easier because when I take the derivative of an exponential, it's itself times the derivative of the exponent times the natural log of the base. And if you plug ln e into your calculator, this is equal to 1. So this last step is not required for base e exponential. So your final answer would be 3e to the 3x. All right, this next example illustrates what happens when I have a binomial exponent. So again, same idea. It's going to be itself times the derivative of the exponent. Now, if I write my answer like that, that's really incorrect because that means that 8x is only being multiplied by the base e, and I'm adding 3. Because the derivative of the exponent is a binomial, you must include that derivative in brackets. Okay, in this particular case, there's a couple ways to do this question, but the easiest way, I think, is to do the chain rule. So bring the 3 out front. E to the 4x plus 1 drops to a power of 2. And then I times it by the derivative of the inside, which is an exponential, so itself times the derivative of the exponent. So now 4 times 3 is going to be 12. And e to the 4x plus 1 squared times e to the 4x plus 1 to the first is going to be e 4x plus 1 all to the power of 3. Okay, I want you to pause the video and give this question a try, as this is one of the multiple choice questions from the 1997 AP exam. Okay, hopefully you've had a chance to try, and again, you notice that this is a quotient rule, so f prime of x is going to be the bottom, times the derivative of the top, which is itself, times the derivative of the exponent, minus the top, times the derivative of the bottom, all over the bottom squared. So if I clean this up a little bit, I'm going to get 4x e to the 2x minus 2e to the 2x. And if I square the bottom, I really get 4x squared. And again, none of those answers match up. So I have to do some more simplifying. So I'm going to factor out a 2e to the 2x. And if I do that, I am going to be left with 2x subtract 1 all over 4x squared. And now 2 goes into 2 once, it goes into 4 twice. And so my answer is question E. Okay, this next question, this is from the same exam. We do require a graphing calculator, and they want to know for what value of x is the slope of the tangent line to the graph of the function equal to 3. So basically they're asking me where is the derivative equal to 3. So again, to do this question, I'm going to take my original function, which is 2e to the 4x squared, to the 4x squared. And I want to take the derivative, so it's going to be 2e to the 4x squared times 8x, which is really 16x e to the 4x squared. So there's my derivative. And they're asking me, where does the derivative have a slope of the tangent line that is 3? Or where does the function have a slope of the tangent line as 3, which is the same thing as saying, where is the derivative equal to 3? Now, the easiest way to do this, because this is part of the calculator portion, is to graph this. Okay, so I'm going to go to my graphing calculator, and I am going to graph my first function, which was just 3. So I'm just going to put in the constant 3 and graph that. And then I'm going to put in another function. And my second function is going to be the right side of my equation, so 16x times e raised to the 4x squared. So the second function was 16x times e raised to the 4x squared. And I'm going to graph that guy. And you notice these two do cross right at this point right here. So I want to now find the intersection point, because that will be where they're equal. So menu, I want to analyze a graph. I want an intersection point. So now I'm going to move my cursor. So that is to the left of the intersection point. I went way too far. Okay, anytime I'm on the left, I'll just hit enter. And then I'm going to move it to the right of the intersection point. It's kind of hard to do with this stylus on my computer. And I'll hit enter again, and you'll notice it's 1.68 is the intersection point. So if we go back to the multiple choice question, my answer would be A. Okay, in our next example, this is from a free response question from 2006. And again, we could probably look at this whole question. Again, this question is a little bit time consuming, but let's go through it. It's saying the function g is given by g of x is equal to e a to the x plus f of x, where a is a constant, and they want us to find g prime of 0 and g double prime of 0 in terms of a, and show the work that leads to your answer. Well, they're giving us some information here. So let's go first of all and find the derivative of g. The derivative of g is going to be e raised to the ax itself times the derivative of the exponent plus the derivative of f would be f prime. If I clean this up a little bit, I'm going to put that constant a in front. And now they want us to find the derivative with respect to 0. So this is going to be a to the 0 plus f prime of 0. And If I put in my values f prime of 0, f prime of 0 is -4, so I know that this is -4. E to the 0 is going to be 1, so therefore g prime of 0 is going to be equal to a minus 4. And they also want me in part A to find the second derivative at 0, so I have to take the derivative of this. Okay, so g double prime of x is going to be, so again I have a to the x, it's an exponential, so it's going to be itself, a to the x times the derivative of the exponent, plus the derivative of f prime is going to be f double prime. Now, I'll just clean this guy up a little bit. Well, if I bring this a out front, I'm really going to have a squared e to the ax plus f double prime x. And now I'm going to evaluate this when x is 0. So I'm going to get a squared e to the a times 0 plus f double prime of 0. Well, e to the 0 is 1, so this becomes a squared. And f double prime 0 is equal to 3. So there would be g double prime evaluated at 0. So again, really not that challenging of a question, but you have to know how to take the derivative of an exponential function. That was part A. Now in part B, they're telling us that, let's see here, the function h of x is cos kx times f of x. So h of x is equal to cos kx times function f of x. And they want us to find h prime and write an equation of the line tangent to the graph when x is 0. So I want to find h prime, and I also want to find the equation of the tangent line when x is 0. So to find the equation of the tangent line, I need slope and point. So we will find the derivative right away, but let's find h of 0 first, okay? I need the y coordinate of my point. So h of 0 is the cos of k times 0 times f of 0. Well, this really, k times 0 is cos of 0 times f of 0. Cos of 0 is 1, and f of 0 was given to me as 2. So therefore, my coordinate, y coordinate is 2. So I have my point. Now, to find the derivative, I have to use the product rule. So cos kx times f prime of x plus the second function. The derivative of cos is negative sine kx, and then I have to times all of that by k. So therefore, I'm asked to evaluate this at 0, so I get cos k times 0 is going to be 0 times f prime of 0 plus f of 0 times negative sine k times 0 is going to be 0, and I still have to multiply it by k. Well, hopefully you know that sine 0 is 0, so this whole part is going to be 0. So I'm really left with the cosine of 0, which is equal to 1, times f prime of 0, which is given as negative 4. Therefore, my slope is equal to negative 4. So now I know my slope, I know my point. So now I can find the equation. So it's going to be y minus y1 is mx minus x1. So it's going to be y minus 2 is equal to negative 4x minus 0. Now, believe it or not, you can leave your answer like this. They haven't asked you for any specific form, so that is a valid solution for this question. All right, the last question is from the 2011 free response question, and it's asking us, we're given a piecewise function, and in part A, we want to show it's continuous. And part B, they want to know for what values of x will the derivative of this piecewise function equal negative 3. So let's do part A first. So I have to, first of all, we're asked to figure out, is it continuous at 0? So first of all, I have to figure out if there's a value of the function at 0. And I would use the top function to do that. So it would be 1 minus 2 times 0, which is 1. And then I'd have to show that there's a limit as x approaches 0 of this function. And because it's a piecewise function, I'm going to have to do the limit as x approaches 0 from the left, and the limit as x approaches 0 from the right. Well, from the left, I'm using 1 minus 2 sine x, and if I plug a 0 in there, I get 1. Coming from the right, I'm using e to the negative 4x. If I plug 0 in there, I get e to the 0, which is 1. So therefore, the limit of this function at 0 is 1. So statement 3, we can say since f of 0 equals the limit as x approaches 0 of my function equals 1, therefore continuous at x equals 0. All right, so now for part B of this question, they're asking us to find, express f prime as a piecewise defined function and find the values of x, which makes the derivative 0. So I need to figure out the derivative. Well, the derivative of the numerator, or of the top function, the derivative of 1 is 0, minus 2, and the derivative of sine x is cos x, and my domain is going to be when x is still less than or equal to 0. And the derivative of e to the negative 4x is going to be itself times the derivative of the exponent, and that's going to be when x is greater than 0. So now they want us to figure out where the derivative equals, I believe it was negative 3. So I'm going to take the top function, set it to negative 3, so therefore cos x, if I divide both sides by negative 2, is 3 over 2. And we know that cos x oscillates between negative 1 and 1, so it's impossible for cos x to go to 3 halves, so there's no solution there. So taking my second derivative and setting it equal to negative 3, again, I'll divide both sides by negative 4. Now I'm back to solving an exponential equation, so I'm going to take the natural log of each side. My rules for logarithms, that negative 4x comes out front, and ln e is 1, so the left side becomes just negative 4x times ln of 3 over 4. And now you just divide both sides by negative 4, and that would be your solution, where the derivative has a value of negative 3. So again, a good question, not that challenging, but you need to know a lot of skills in order to tackle this problem. Okay, there is a handout for you to work on the derivatives of exponentials, so I'll give that to you in class, and please try those 20 questions.